So I'm going to show the answers. And then any questions you have, we'll go through those. So for the first one, you need to define your variables after we go over this. First, if you didn't do that, make sure that you do that for all of your word problems. You need to have variables and define them if they're not given. They don't have to be the same as mine. You just have to tell me what your variables mean. And you have to be specific. So don't just say A equals apples. Tell me what about the apples don't we know. Right, and then for this one, you just needed to write the equation. You could have solved this. I don't know what the answer would be if you solved it. But you just need to write your two equations. So one should have all of your money, 1.25A or whatever you use, plus 0.95R or whatever you use, equals 2260 would be 1. The other one should equal your total number of pieces of fruit, because A and R, or whatever you use, are both representing number of fruit. So A plus R equals 20 would be your other equation. Questions on number 1? Number 2, you could have solved this a bunch of different ways. I just used Desmos. Changed the A to X and the S to Y, and I just put that into Desmos. So remember to define your variables. Again, be specific. Here we're looking for number of student and adult tickets. Your two equations should be A plus S equals 238, and 6.75A, or whatever you use, plus 3.50S equals 1,352.25. However you solve that, you should have got 109 for student tickets, or number of student tickets. Does anyone need to see substitution or elimination or graphing for that method? Which one?
I just had a question about the test. Because if you use graphing, how do we show it?
We'll get to that. But this same way we've been talking about, if you're using Desmos, you would show me that you change these to X and Y, show me your answer.
Everyone?
There's one on graphing, one on algebraic, which is elimination and substitution, and one on word problems. Okay. Skip number 3, move on to number 4. For this one, define your variables. I use C and B, but you could have used whatever you wanted. Be specific when you label them. Number of cards, something related to that. Then your two equations. One should represent this first sentence. Susie's brother has 10 more than twice as many cards as Susie does. So this is talking about the brother, so this should be brother equals 2 times Susie's number plus 10, or if you read it backwards, same thing. If I start with Susie and I multiply it by 2 and then I add 10, I get Susie's amount. And then the other one together, they have 70, so that should be your two variables added together. This was a good problem for substitution. So if you take the brother's equation and put it in for B, then you can combine your like terms and solve for Z, which is what we needed, or whatever you used, to get 20. Hold your question in 1 second. If you go back and double check this, it does work, because then B would need to be 50. 50 plus 20 equals 70, and 20 plus, or times 2 equals 40, 40 plus 10 equals 50. Okay.
On the test, would there be a question like this that you want to get elimination?
Where you would only use substitution,
Yeah.
there will be problems that say specifically to use substitution or elimination. Cool. Okay. Did anyone solve this one by elimination or graphing and want to see either of those? Alright. If you got a review from me last class, raise your hand. I don't know why I keep doing that. Alright. We are going to go through some of these questions, not all of them. If there's one that you see that you want to go over while we're working, circle that and we'll come back to it and do it if we have time. The first one we're going to do by graphing is number 4. So for number 4, yes, you will have Desmos. Yes, you can check these in Desmos, and that's a really good way to check for all of them. But for graphing, I still need to see graphs. And if you have any problems where you need to solve them, for graphing, I need to see that. So you would need to get both of these in slope intercept form and graph them. So for this, we would need to subtract 8x on both sides for both of these. I'm going to do this simultaneously. So when we do that for the first one, we would have 3y equals negative 8x plus 12. For the second one, we would have 3y equals negative 8x minus 9. Then we would divide everything by 3. Right now, we're not using Desmos, so no one should have their computers open. So the first equation would be y equals negative 8 over 3x plus 4. And the second one would be y equals negative 8 over 3x minus 3. Without graphing these, what do we notice about these two equations? Felix? They have the same slope, which means what? They're parallel, which also means what about the solution? That we're going to have no solution. They're not going to touch. So you could write that without graphing that. Wow, that was supposed to be an S. But you still need to graph the two lines as well. So for this first one, we have a y-intercept at 4. Our slope is negative 8/3, so we would go down 8. And to the right 3. What were you asking about? Oh, sorry.
Okay, so I'm looking at the right on the equation. 3y equals 8x plus 12. So you divide by 3. Okay, got that. Why does the 8 still have the 3?
This isn't a nice fraction that we could easily simplify.
Oh, okay.
So the x is gonna be rising around, like the number after that.
So even though we divided by 3, 8 divided by 3 is not a nice number. So it's going to stay a fraction.
Oh boy.
I mean, okay.
Eliminating teaching factor of multiplication by 5 or 8.
By 8. It looks like a 5, but this is an 8.
And the graph for the infinitely many solutions would be the exact same line, right? Like it would have to be the same line or step too.
Yes. Same y-intercept, same slope, and you could just draw one line and draw like it with double arrows or with highlight over it or something like that. Your second line, you have a y-intercept at -3, same slope, and now we're going to go up 8 and left 3. Wow, you cannot see that. It doesn't really match the way. They are parallel. So you should have both lines graphed and your solution, which in this case is no solution. So you can write out the words no solution, you can write NS, you can write the 0 with the line through it, any of those. Yes.
I don't have a question.
Okay.
Sorry.
It's okay.
Actually, I do have a question.
Okay, ask it.
I'm sorry.
It's okay.
Okay, so in the purple on the top two,
Okay.
I understand how you got the second one, not the second one, great. Where did the 4 go?
What for?
The 4 is the line.
These are not related. The second part is for this second equation. Everything goes for the second equation. That's why this is 4 and this is 9.
Okay. Oh,
It's like you love
Yes.
I'm smart.
Yes. Yes, you are.
how did you get 8x times 8x?
I'm sorry. I missed the first part. How did I get what to be? What did it be?
-8x times 8x. What should that equal?
0.
So wouldn't it disappear?
Correct. It disappeared on this side, so we moved it over.
I don't know another question.
No, you're fine.
So, why is -8x the only thing that remains with the res overrun? Is it because it's y?
I think those are two different questions. And I'm not sure I truly understand your question. You're asking why is this still a fraction?
Like the second one, okay? And if you look down, yeah, right there. That one. Why does that one still have 3?
Put in your calculator 8 divided by 3.
Okay. Wait, wait.
Same thing.
Okay.
Same difference.
8 over 3 it is. Calculator's not even on. 2.6 repeating.
Right, we're not going to graph that. We're going to leave it as a fraction. So when we divided this by 3, instead of putting 2.6 repeating, we left it as a fraction.
Okay.
Any other questions on this one? Move on to the next page. We are going to do substitution now. We're going to do a few of these. 7, 8, and 11.
Is it 11?
7, 8, and 11, yes. Okay. For substitution, remember that you need to have an x or a y equation. Do we have that in number 7? No. That means we need to solve one of these equations to get that. Doesn't matter what you solve, but if you pick anything other than the variable that has a coefficient of 1, you're going to have fractions, which is fine, but just be careful when you have those fractions.
So, wait, say it again?
If I were to solve for this x instead of this y, I'm going to end up with fractions. And the equation I solved, when I substitute, up until the end. The very end will give you whole numbers, but everything else would give you fractions.
So why is that? Because you have to divide.
Because I would have to divide by 3. Okay. So for this, I'm going to subtract 3x on both sides to get y equals negative 3x minus 3. Now we have an equation that is solved for y, so we can take this equation and substitute it into the other one, where y is. You don't have to draw the arrow, I'm just doing that so you see it. So this would become 6x plus 2 times our negative 3x minus 3 equals negative 2. Good.
Okay. So, y equals 3x minus 3.
Negative 3x minus 3. But yes.
Negative 3x. Okay. Cool. So negative 3x minus 3. How did you rearrange that?
We're substituting what y equals into where y is.
Okay. Okay, so. Okay,
And then solve.
I got it.
When you go to combine your like terms, what happens? Yeah. Yes. Both of those things. These cancel. Don't put 0x because then you're going to have a habit of bringing that x along and making it a very something that is not. Just don't put anything except 0. These cancel, so you're just left with negative 6 equals negative 2, which is no solution. Remember with your substitution and elimination, as you're solving these, you'll know very soon in your solving process whether it's no solution or infinitely many, because you won't get an x or a y.
Is there no solution for like 0 equals 0?
That's infinitely many.
Wait,
So infinitely can only be 0.
Infinitely many can be two numbers equaling the same thing. 2 equals 2, 10 equals 10.
Negative 2.
actually,
Other questions on 7 before we do 8? Other questions on 7 before we do 8? Yes. For number 8, do we have an equation that solves for x or y?
No.
No, so we need to solve one for x or for y. The second one for which variable?
X.
X. Because if we solve it for y, we're going to end up dividing by 4, so we end up with fractions.
wait, we're solving for x?
We're solving for x. So we would subtract 4y on both sides to get x equals negative 4y minus 3. Now that we have x and x equations, we can take that equation and substitute it back in to the first one where x is. So that would be 2 times negative 4y minus 3 minus 5y equals 7.
I have a question.
Ask it.
What is the point of minusing 4y on both sides if we still end up with x equals negative 4, right?
We're trying to get x by itself, so we have to move it to the other side. So when we subtract it, we're not really subtracting it, we're really just moving it. Okay. So when we distribute, you have negative 8y minus 6 minus 5y equals 7. Combine your like terms and you would get negative 13y. Add 6 to both sides and you would get 13. And then divide by negative 13. Jenna?
I got the same answer, but like in a fraction.
Because you didn't solve for x at the beginning.
Oh, you know what I'm talking about. Oh yeah, I see.
Right, so now that we have y, we're going to go back and solve for x, or figure out what our x is. We're going to put negative 1 into this equation. You can put it into any of these three, but I'm going to use this one. So we would get x equals 4 minus 3, or x equals 1. And then because this is one solution, we have to write it as an ordered pair. So 1, negative 1 would be our final answer. Questions on number 8? Moving on to 11. For 11, we have two equations that are both a y equals. When we have something like that, what do we do with the equations? Yes. Set them equal to each other. So this would be negative 4x plus 8 equals negative 3x plus 8. Does not matter which side is on which.
Oh.
Erica? Yeah. From there, you're going to choose what you want to move. So whatever you want to move first.
Is this all substitution?
Yes. Negative 4, because we substituted each one into each other. So if we're moving the negative 4, we would add 4 to both sides.
Why did they make them each other?
Since they're both y equals, I can say that I could put this in for this y, and that would be this, or I could take this and put it into this y.
I understand. Okay.
And then we would need to move our 8. Here we get 0. Remember that x equals 0 is a solution. I don't know why I lost it in. Anyway.
Oh.
Yes.
If we get the y equal to x,
Say that one more time.
Put like 0 equals 1x, would it still be right? It doesn't matter.
Sika,
How do you 0?
what is 8 minus 8?
But what happened when we did the negative 3x?
You tell me what that is. What is negative 3 plus 4?
1?
Okay, so that's 1x. And then we had to move 8 to the other side.
Why don't we do 8 minus, like, why don't we subtract the 8 first?
We could have done that. No. Because even if you were to get rid of the 8s first, you still need to move your x's to the same side. That does not become no solution. I meant to do it the other way, but that's okay. You still wouldn't get no solution. The only way that would happen is if they would cancel out. The variables would cancel out. Okay. Now that we have x equals 0, we're going to take that, put it back into one of our equations to find y. It does not matter which one. And it would just be 8. Which we also could have seen because both of these have the same y-intercept. So when we write our ordered pair as 0, 8, it kind of makes sense that that is the point they share since they both have the same y-intercept. Other questions on 11?
Can we do number 9?
After we, yeah, circle it and we'll come back to it. 9 is on this page. Okay. On to the next page. We're going to do 15 and 21. For 15, remember for elimination, our variable coefficients need to be the same. Do we have that here? So if we don't have that, then we can choose whether we want to eliminate x or y first. Y, okay? What would be the easier of the two? So to eliminate y, we need to make them both the same. That means we need to make this y the same. So we're going to multiply this by -6, or you can multiply it by 6. In this case, it doesn't matter. Because if you multiply it by just 6, then you would need to add. If you multiply it by -6, then you would be subtracting. So it's up to you. I'm going to say -6, so that way it's exactly the same. So this would be -18x minus 6y equals whatever that is.
Positive or negative?
Yes. Okay. And then to eliminate our y's, would we add or subtract? Subtract. They're the same whether they're positive or negative. We are subtracting. So -4 minus -18, that would be the same thing as adding them together. -4 plus 18 would be 14x.
Wouldn't that equation have to be on the top?
It doesn't matter.
Why is it positive 1, 2, 6?
What's a negative times a negative? Jenna.
Oh.
-6y minus a -6y would be the same thing as -6y plus. So those would cancel. And 0 minus 126 would give us a -126. Divide that and tell me what y is. Or x is
9.
9,
What is,
Negative
what is
9.
126 become?
because we're subtracting.
Oh, yeah, on top.
Yes.
So what the 126 positive?
It was, but we're subtracting 0 minus 126. Okay. And now we need to put this into one of our equations and find y. Doesn't matter which one. Sure. So we would have negative 27 plus y equals negative 21. Add 27 to both sides. And y equals 6. So our order pair would be negative 9, 6.
Wait, so y by itself equals 1, right?
You're talking about this y right here? Or this y?
Yeah, that one.
Yeah, it'd be 1y. What questions do we have on 15? Moving down to 21. Do we have coefficients that are the same?
Yes.
Yes and no. They're similar. I should have said, do we have similar coefficients? One is positive, one is negative, which is fine. So we can eliminate our y's by doing what? Adding. Wow, that was a terrible line. For these, make sure that you're showing me whether you added or subtracted when you get to the elimination process. So if we're adding these two, x plus a negative would be the same thing as x minus, so that would be negative 4x. Negative plus a positive would cancel those out. 11 plus a negative would be 11 minus 23, or negative 12. And then divide. Then we could use that and go back and find y. I'm going to put this into the first one. 3 minus 2y equals 11. Subtract 3 on both sides. And divide both sides by negative 2. So our order pair would be 3, negative 4. Questions on 21? Right. On to the word problems. We're going to do the last one. 26. Evelyn. Yes. Hey, read this. Tell me what's important. 26 is the one we're doing. What's important here?
I think that is like listed out.
Yeah, basically everything right here. All of that information is important. What are we looking for?
The cost for the Ferris wheel and the water.
Cost of how much it to ride the Ferris wheel and how much does it cost to slide on the water slide. Okay, so those are going to be our variables. Call them F and W, W and S, X and Y, doesn't matter.
Wait, which one's that? Which one's that?
I already told the water side cost.
Okay, so let's set these two equations up. Because each X is like the number of times their ticket was stamped, this would be 3W or 3, whatever you called it, Jenna.
On the test, are we gonna have to put F equals cost of Y?
Yes, for every single word problem.
On the test, can you just use X and Y?
Sure. Unless there's a problem that gives you different variables, then you need to use the variables given. This one has 6 numbers, so we're going to use all 6 in the equation. So this one would be 2W plus 3F equals 1555. How do we want to solve this? Go ahead.
Elimination.
Okay. Elimination would work. Graphing would also work if you did it in Decimals, not in the calculator because you have a lot of fractions. Substitution would work, but you would have fractions.
Could you just figure out the cost of the water?
Yes, using elimination. So here we could eliminate our f's by subtracting. And when we subtract the entire equation, 3 minus 2 gives us just 1. 1770 minus 1555 is 215. These are word problems, so we need units. We're looking for cost, so our units would be dollars. Then we found W, doesn't matter which one you choose. Put it back in for W and solve for F. This would be what, 430? And then we could subtract. 3F equals 1115. I'm not certain about that. Double check that, please. Okay. Yeah, that makes more sense. And then divide that and tell me what you get for F. $375. Okay. For your word problems, box in your 2 answers, or maybe write them together and box them in, just so I know those are your 2 answers. It's final. That's the end of it. Those are all the questions that I wanted to go through. I heard 9. Were there any others that anyone wanted to see or go through? That one. I'm gonna go through and I'm gonna circle them first and then we'll come back. So 1. Kayla, did you still want to do 9?
You don't have to. I did check. I just wanted to see one.
Okay. Evelyn?
16.
16. Any others? One and 16. If you find one as we're going through these, let me know. Okay. For this one, is this going to be no solution?
No.
No. Is it going to be infinitely many solutions? No. So we know it's going to be 1. They're going to cross somewhere. We just need to graph them and figure out where that is. So for the first one, y-intercept of 3, slope of 1/3, so we can go up 1 to the right 3, down 1 to the left 3, and make that line. That was almost accurate.
Oh, wait a minute, I went the wrong way.
Don't do that. Okay, and then for the second one, we have a y-intercept of 1, slope of -1/3, so we're going to go up 1 to the left 3, down 1 to the right 3, -3, 2 would be our solution, but we still need to graph it.
This is a long equation. Oh my god. I want to.
Michaela?
Back to the word problems. How would you like us to write our final answer? Like, for the last one, we just did write like $2.15 for a water slide.
You just say W, whatever your variable is equals the, so if it's cost, you just need $, the amount. If it's amount of something, you can say 15 apples, whatever the variable is.
Okay.
Usually it's just one of those two things, cost or amount of. Okay. Questions on 1?
Oh, I peed somewhere.
Sorry. When I was in high school, I purposely avoided PE and I did weightlifting all the time instead.
I love
We can't do
PE.
weightlifting.
Someone said something that I didn't hear what you said.
We can't do weightlifting.
I can't do weightlifting programs. Yes.
Can I go to the bathroom?
Yes.
Is that we go to right now? No, where? There's stuff isn't there. Where's it go?
There's the first one.
Right. For 16, do we have a common coefficient? No. We have to make one. Do we want to eliminate our x or our y first? Okay. So for x, we would need to make these both the same. Multiply the first by -3? Sure. You could make these a bunch of different things. You could just change the first and make them both 9. You could change them both to 18. Change them both to 27. You have choices. Whatever. So if I multiply the first equation by -3, that would become positive 9x, negative 24y, and positive 18. No solution. It's going to be no solution, yes, but still solve it. So we would do what to eliminate these? subtract. 9 minus 9 gives us 0. These would also cancel and become 0. 15 minus 8 would be negative 3, but it doesn't matter because this is going to be no solution. Any other questions?
Oh, I figured it out. That's no solution, just solve it.
Right. For the remainder of class, you guys have the rest of these problems to work through. If you finish those, you can work on Khan Academy or Delta Math for the work homes if you haven't done those already, or previous Khan Academy and Delta Math for systems. If you have questions, you can come up to me because I have some stuff I need to do with whatever question you may have. Anyone have questions right now on what we're doing for the remainder of class? You guys have this time to work.